Okay, so let's go to the stoichiometric air calculation for gaseous fuels. Now, for gaseous fuels, so the fuel analysis will be given in terms of volumetric or in terms of our molar analysis. So you will notice here, I have here the figure or our combustion or combustor area, no, where the combustion takes place. So we need to supply the volume of air going inside the combustor and also supplying the volume of fuel going inside. Then after the combustion takes place, so we have the volume of air as the product of combustion at this side. Okay. Now to compute the stoichiometric on molar air fuel ratio, so we have here the equation for your air fuel ratio. So that will be the moles of air divided by the moles of fuel. Okay, so that will be represented as small letter n and modify as air, and we have n for your fuel. Okay, or it can be equal to volume of air, volume of fuel. So from here we can derive, we can see that the units of the product of our stoichiometric or air fuel ratio is in terms of volume, no? Volume of air, volume of fuel. Now, now for the gases, so air fuel ratio in terms of volumetric ratio. So we have your molar air fuel ratio, that will be the volume of air divided by the volume of fuel. Now for our, so this is your stoichiometric, no? Now for this for combustion which have an excess air, so that will be multiply 1 plus your E air, so that is 1 plus your excess air. So the units, we have cubic meter of air and cubic meter of fuel. Now to solve the stoichiometric molar air fuel ratio, so we have your step 1, so we need to assume that 100 moles of fuel to eliminate the long decimal points. So assume that one. And step 2, we write out the combustion formula, that will be fuel and plus your air, and we have your products. Then for step 3, so we need to write out the molar equation by balancing the reaction using the principle of mass conservation. So after that, we have your step 4. So let's have your create our molar air fuel ratio, that will be equal to the moles of air divided by the moles of fuel. So we have the symbol. Then take note, palagi ito, no? Ang moles of fuel natin are always equal to 100, no? So 100 moles. So take note of that one. So ito yung pinagkaiba ng analysis of gaseous fuel versus to the so pinagkaiba ng liquid fuel versus to the gaseous fuel. So take note of this one. So we are using the moles of fuel as a 100. So let's have our sample problem, no? So fuels having a volumetric composition of 83% methane, so that will be CH4, the chemical formula for that one. And we have 12% propane, so that will be C3H8, and we have 5% ethane, that will be C2H6. So it is burned in 50 excess air. So if the gas flow rate is 100 liters per second, so what will be the blower capacity in cubic meters per second is required in the combustion chamber? Now our ambient air is at the 32 degrees Celsius at 754 torrs. So I bring down here the figure, no? So we have here your combustion chamber, okay? So where the combustion takes place. Now we have here supplying the volume of air in the combustion chamber. Then I will be supplying 0.1 cubic meter per second. So that is the volume flow rate of fuel, that will be gaseous fuel supplying in the combustion chamber. And we have here the output, that will be the volume of the product of combustion. Now we have step 1, so we're going to assume our moles of fuel are 100. Then let's go to step 2. So we're going to write out our fuel plus air. Then we have your products. So our fuel na meron tayo so we have 83. That would be CH4, no? So if I'm going to write that one, so we have here 83. So that would be CH4. Then I'm going to add another, we have 12%. So we have here 12% of propane. So that would be 12 times the chemical formula of propane. So we have C3H8. So that will be C3H8. So again, we have another fuel, which is ethane. So we have 5% of that one. So I'm gonna write here that will be 5 times your C2H6 for the chemical formula for your ethane. Then next, okay, so that will be our fuel now. So this is our fuel. Then I'm gonna add your A, which is yung unknown natin, no? Then I'm going to multiply that by your oxygen plus 3.76, okay, of your nitrogen. Then our product here, that will be B, no? So that B, we have CO2. Then we're going to add the value of your unknown value of C. So that will be your H2O. Okay. Then I'm gonna add here your A, which is our unknown, times that will be multiplied to 3.76 of your nitrogen. So this equation, that what we have here, that will be combustion formula. So this is without excess air. So next we're going to do step 3. So that we're going to do is to balance the reaction. So let's start with your carbon, no? So let's start with to balance your carbon. So what we have here for your carbon, so that will be 1 times your 83. Okay. Then for this one, for your propane, so that will be 3 times your 12. So I'm gonna add that one, that will be 12 times 3. Then next I'm going to add for our ethane, so that will be 2 times 5. So I have here 2 times 5. Okay, then I'm going to equate that one for on the product of the combustion. So we have your B, so that will be times 1. So since wala naman siyang corresponding coefficient dito. So we have the coefficient, the value of your B. Okay. So summing that one, so we have the value of your B. So your B is equal to 129. Okay. Then let's go to hydrogen. Now for the hydrogen, what we have here, we have your H for your methane. So we have 4 times your 83, no? 4 times your 83. Then I'm going to add dito naman pagdating sa ethane, propane, we have your 8. So 8 times 12. So that would be 8 times 12, no? Then add natin also, we have 6, no? This one, 6 times 5. So that would be 6 times 5. Then on the product of combustion for our hydrogen here, so taking a look at, we have the coefficient of C, which is equal now to your C multiplied by 2. So we can sum up and divide the value. So we have the value for your hydrogen, that is 229. So next let's go to the oxygen. So we have your oxygen. No. For our oxygen, we have the values of On this side, we have 2A. So this one, we have 2 times A. Then on the product of combustion, we have 2 times B. Plus, we have your C dito. Okay? So, since the given na rin yung ating, call this, given na yung value ng ating B, and also, nakuha natin ang value ng B, and also the value of C. So, we can substitute here to get the value of A. So, we have here A now is equal to 2 times 129, no? Plus the value of C, which is 229. Then, I'm gonna divide this one by 2. So, we have the value of A, which is equal to 243.5. Now we can finally rewrite our air fuel ratio. So substituting yung values natin yung nakuha natin from here going there. So we have now 83, no? Your fuel. So we have your 83 CH4. Then that will be 12 C3H8, then plus 5 C2H6. This is our fuel. Then the values of your A, so that will be 243, no? So we have 243.5, that will be multiplied to O2 plus 3.76 of your nitrogen. Okay, then we have your product. So the value of your B, which is 129 times your CO2 plus your value is that will be the for the value of C, we have 229 times the value for the H2O. Then this one, so that will be 243. So this is 243.5. That will be multiplied by 3.76 for your nitrogen. We can further rewrite our equation or combustion formula into, so let's distribute this value here. We have 243, no? It will be 243.5. Now for your coefficient of your oxygen, then multiplying 3.76 by 243, we have 915.56. So that one, 915.56. So we have for your nitrogen. Now for the on the other side for our product, so again we can rewrite that one. That will be 129. With CO2, 229 for your H2O, and this one, so the same as also this one. So we have 915.56 for our nitrogen. So let's proceed to step 4. So that will be 100 moles. Okay, so that will be our fuel, no? So we're going to assume 100 moles of fuel plus 243.5. So that we have your oxygen here and 3.76. Then we have your products. So ito yung magiging general form niya when we're using a 100 moles of fuel. So we're going to assume a 100 moles of fuel. Now, I'm going to write yung stoichiometric natin air fuel ratio. So we have your stoichiometric air fuel ratio for this one. So we can write that one. That will be equal to the moles of air divided by the moles of fuel. Okay. So for the moles of air, we have this one, 243 times oxygen plus 3.76. So since we have the to get the moles natin dito, so we have 243, no? 0.5, that will be multiplied by 1. So we have a corresponding moles for this one, that will be 1 plus 3.76 for the coefficient moles of nitrogen, no? Then we're going to divide this one by the moles of fuel. So take note, so we'll be using 100 moles. So I'm gonna write here 100 automatically. So we have 100 moles. Now to use get the quotient of this one, so we're going to divide this one. So we have the quotient of this one, that will be your air fuel ratio, no, stoichiometric. So that will be equal to 11.6. So unit nito, take note of the units, that will be cubic meter. So that will be cubic meter of air divided by the cubic meter of fuel. So we have here the stoichiometric air fuel ratio. Now taking note that our air fuel ratio, no, our air fuel ratio is equal to volume of air, B air, divided by the volume of your fuel. And this is equal to your stoichiometric air fuel ratio. So that will be 1, no? That will be 1 plus E. So 1 plus your excess air dito. And this is the units of cubic meter of air and cubic meter of your fuel. Now, we can substitute your stoichiometric here for your actual air fuel ratio, no? So stoichiometric, we have the values, which is 11.6. So that will be cubic meter of air, cubic meter of fuel. Then I'm going to multiply this one from our excess air. So taking note that we have 50% excess air dito sa problem given. So I'm going to multiply that one plus 0.5 for your excess air. Then finally, we can multiply that one distributed. So the values of this one, we have values of 17. So this is 17.4. So that will be the cubic meter of air divided over the cubic meter of your fuel. Now the question in the problem is that what blower capacity in cubic meter per second is required in the combustion chamber. So taking note that here we have volume of air and also volume of your fuel. So we can rewrite, or we can equate this one into volume of your air, no, divided by 0.1, which is our 0.1 is the volume of your fuel being supplied. So that will be 0.1. So it is the same. So that will be volume of your fuel. So I'm going to write here 0.1. So this will be cubic. So this will be cubic meter per second, the units of this one. Okay, so we can rewrite the equation. So we can find the values of volume of air from here. So we can rewrite now to get the values of volume of air. So that it is also the will become the blower capacity. So we have now your volume of air is equal to 17.4 cubic meter of air, cubic meter of fuel. So I'm going to multiply it by 0.1, that will be cubic meter per second. So this is already in terms of fuel, cubic meter per second of fuel. So I'm going to cancel out here units. So we can write now the blower capacity, or the volume flow rate that required to supply the combustion chamber. So we have now, that will be 17.4 times 0.1. So we have 1.74. So that will be the cubic meter per second. So that will be our blower capacity. Okay, so that answers the questions in the problem. So okay, take note. So let's have a quick recap, no, on the steps. So again, we have step 1, so we're going to assume 100 moles of fuel. Step 2, we're going to write the fuel plus air, or the combustion formula. Then you have your products. So we write that 1. So then we have, now this is for the without excess air. No, so this is a stoichiometric combustion formula without excess air. Now from there, we're going to balance the reaction. So from your energy mass balance, so we have the product, we have the values of that one. Then rewriting the combustion formula, substituting yung mga values of your unknowns of A, B, and C. So we can rewrite, and finally we can come up with this combustion formula. Then step 4 for your air fuel ratio, no? So again, so we have 100 moles of fuel plus your air, that will be 243. So this is the values that I have nakuha dito. Okay. Then finally, our stoichiometric air fuel ratio, that will be the moles of air. So take note, moles of air, ito yung part na yon. Then divide by the moles of fuel. So take note, we're using 100 moles. Take note of that one. Compare doon sa liquid fuel. So iba yung assumption in terms of gaseous fuel. So we divide 100, no? Then we have finally the stoichiometric, that will be the value 11.6 cubic meter of air. So this is the stoichiometric. Now to get the excess air, we just only multiply, no, by 1 plus your excess air. So multiplying that one, we have the value of 17.4. So this will become your actual air fuel ratio. So since we have the value of air fuel ratio, that will be equal to volume of air and volume of fuel. Since the problem, binigay na yung values ng volume of fuel that is given, no? So we can manipulate our equation. Then finally, we can get the value of your volume of air. Okay? So that's it.